Hi, everybody. Thank you for being here. My name is Elise, and this is Pepper. I work for Aldebaran, the company that is behind Pepper. And today I would like to share with you our vision of the future of robotics and why, as developers, you should pay attention to it. So, before introducing you to Pepper, I would like to talk a bit about the notion of robots. Because the funny thing is, when you talk to someone about robots, what comes to their mind most of the time is the picture of a humanoid shape plus some intelligence. But actually, if we look like at the definition, a robot is simply an electronic machine programmed to do things autonomously. So this actually includes a very wide range of different things. And what we do is indeed inside the field of robotics, but not only. Since few years, we have seen new fields that are being explored, and they are in some way connected to robotics. So to give you a precise idea of what we do and of what Pepper is, here is a little illustration. So Pepper is right at the middle of these three things. We have robots that we just defined, so it can be robots like Roombat, it can be industrial robots like mechanical arms, and we also have something called social AI, which is computer software that are capable of intelligent behaviors. And by intelligent, I mean human intelligent. So for example, we have something like IBM Watson that is capable of understanding the human dialogue, the human way of talking, and to have a normal kind of conversation with human and to answer very precise questions. We also have the humanoid, which are simply devices that have an overall appearance that is based on the human body. So what we do is at the intersection of these three fields, we build humanoid companion robots. So they have all the robotics part, they are also companion, they are social, and they have the humanoid shape. So to illustrate this, I'm going to let Pepper, and I think we have a mic here. Wakey, wakey.
Hi, Vox Ticino. I'm Pepper. It's a pleasure to be with you today.
So, Pepper, introduce yourself. Introduce yourself. Okay, I'm going to show you something. Dialogue. So here, oops, where did it go? Anyway, so Pepper, introduce yourself. Can you introduce yourself? No? Someone is a bit shy? Well, I'm going. Tuck, tuck, tuck. Sorry. So, dialogue. I'm looking for Pepper's. Nope. Oh. Little technical issue. So, where do you come from?
I was born at Aldebaran, in Paris. The company was founded in 2005 by Bruno Mazinier, who dreamed of creating the new species of humanoid robots to benefit humankind. It is named after the brightest star in the Taurus constellation. The adventure started with the creation of Now, a fully programmable humanoid robot which is now a standard in research and education for primary, secondary, and special education, with more than 7,000 Nows sold around the world. On June 5, 2014, Bruno and Masayoshi Son introduced me, Pepper, to the world.
Okay. So, I don't know. Can you turn around? Can you turn around? Turn around. Nope, visibly. What about emotion? What about emotion?
I can express emotions with my voice, gestures, and tablet, as well as the colorful lights in my eyes and on my shoulders. I'm still learning how to understand human emotions, but I can analyze your face and notice when you smile or frown. And I can listen to your voice for signs of frustration or happiness. Every day I'm learning and striving to become a better companion.
Okay. And Pepper? Yes, I'm here. How do I feel? What is my mood?
Well, let me check. I have evaluated your mood to happy. You look like an idiot when you smile like this.
Thank you. Okay, let's try that again. What is my mood?
Well, let me check. I have evaluated your mood to angry. You should calm down before your processor overheats. Trust me.
Good advice. So, what can you do? I don't know. Can you guess my age?
Well, I can try. You have 10 years old and you are a female.
Okay, that was not right. The light, probably. So, okay. Take a picture. Take a peek. No, you don't want to. Take a break. Take a break. A break?
Have a Kit Kat.
Okay, thank you, Pepper. So, yeah, no. Trying to put that full screen. I don't know. Technology. Ah. So yeah, that was a transition. So the next question, now that I've presented Pepper, is why do we do this? And here is the start of the answer. We have been developing interface to communicate with machines. And we started from very basic interface, like a lever, and we are working to develop interface that are easier for the human and more intuitive. So we believe that robots are a new kind of interface to communicate with machines because they allow you to have a very social and natural interaction as a human. But the good thing is they are as well interface towards other systems that can be physical systems, like other devices, I don't know, like a Roombat or your home automation systems, and that can also, they can also be interfaced for to get data from online services, for services hosted on the cloud. So, yeah. Here, this is why we do this, and this is what Aldebaran has been doing. Oops, sorry. So this is the first thing. The interface is more intuitive. And then people might start to ask, okay, but what's the difference here between this and Echo from Amazon, for example? And the answer comes with the humanoid shape and the social behaviors. Because when you have these two layers, the cool thing is that technology disappears. The machines, you don't see the machines. You see something you want to engage with. I have never seen anyone trying to hug Echo from Amazon. But a lot of people, they want to touch paper, they want to engage with, and the same goes with Now. So this is the difference. If Amazon Echo fell from the table, I'm going to think, oh, is it broken? But if Pepper fell down, I'm going to think, oh, is it injured? And that's the difference between the two. So that's what Aldebaran have been doing for the past 10 years. We are creating humanoid companion robots. So as Pepper said, it is not the only one. We also have Now on the left of the picture. It's the first one we've created 10 years ago, and is now used in a lot of fields: education, research, special education. And we have also Romeo, that is kind of like our Formula One. It's a big research project in robotics, and he is meant to help and assist people in their home. So, yeah, that's pretty much what we do. And now let's geek out a bit and look at the cool part, which is the tech part, because this is cool, but there is a lot of technology behind. And if we have a look at the hardware part of Pepper, basically it's a bunch of mobile sensors. There is a lot of different things. You've got cameras, you've got 3D sensors, you've got inertial sensor in the body, and there are also a lot of things for the navigation, like lasers and sonar. So yeah, there is a lot of things you can take advantage of, and that helps the robots to understand the environment he is in. Quickly on the component part, it's a B-Trail processor running on Pepper's head. And as he said, there's like 20 motors approximately, and it lasts around 20 hours on the battery. So regarding the connectivity, you can access to the robot via Wi-Fi, or there is also Ethernet connection, and we are gonna do it right now. So it's not painful. You take off Pepper's head, and there is an Ethernet slot somewhere here. Yep, here you go. And now you are able to access and to program the robot. So we're gonna check that a bit later. But yeah, so for all of these components, you need a software layer, which is why we built something called NowKey. So basically, this is the operating system running on the robot and running on all of our robots. It's a cross-platform, so you can run it on your desktop or you can run it on the robot. And it's also cross-language. You can program the robot in C++ or Python, but also other languages like Java, and we're gonna check that later. So regarding the architecture, it's pretty simple. NowKey gives you access to different services. So here is 3 of them, but we have a lot of services available. And all of them are made of different methods that you can call. For example, we've got the HAL memory services, which is handling all the data and memory things. You can get data, you can raise event and do a lot of things thanks to the module. So on top of that, we also have something for what we call the aliveness of the robot. So it's something called autonomous life, and it's also on the robot. And basically, this is what helps you to trigger application. So it's at all time connected to extractor and getting data from the real world context the robot is in. And according to the trigger condition you programmed and to the application that are running on the robot, it autonomously launch either autonomous activities or focused activities. So it can be spontaneous if you program it so, or on command. So this is what gives the impression of aliveness on the robot. And it's very important. But autonomous life does nothing if there is no application running on the robot. And this is where it gets interesting for developers, because you can create those applications. So for that, we are providing different resources. The first thing is something called Choregraph. It's our software programming. It's a programming software, so it's a visual IDE. And it's a very easy, it's a very simple system of drag and drop very visual that allows you to program on the robot. So it's mainly in Python. And we also provide SDK for Python, C++, Java, and JavaScript. So I would like to give you a little, oh yeah, and they are all available on our website for free, along with all of our documentation, our other resources. And yeah, so I would like to give you a quick overview of Choreograph to show you how easy it can be to program on the robot. So, stop. I'm taking this here. Oh. Here. Okay. So this is Choreograph. So, first thing, you have a different window. The first cool one is the robot's monitor. So, yeah, it's not moving, but if the robot moves in real life, it's gonna move on your screen. And if you don't have a robot, there is an emulator inside the software that you can use. We have also different information. For example, this is the data stream from Pepper's camera. It's not recording, don't worry. Then, so you have your project on the left. And there is the interesting part. This is what we call the boxes library. Choreograph is based on a system of very standard boxes that we are providing. So every boxes does an action, a specific action. And some of them are very basic and some other are a bit more complex. So you can just, like, for example, take one box, drag it into the main plan, and you connect it in the application. So all the boxes are connectable between each other. And if you want to dig a bit, they are all made of Python script. So you can either make your own, no, not that one. You can either make your own box or modify, customize some existing boxes. And basically there are boxes for a lot of different things. So I'm going to show you the little So the little demo we did just before that was supposed to work is here. I'm not sure you can see very well. Okay, here you go. So this is something I programmed just before, and it's quite simple actually. So we have different boxes connected to each other that lead all the application. You can write your own script, as I told you. So for example, okay, it's opening over there. Come on. Here. No, not here. Here. So, yeah. This was just a super little script to get the data that the robot get when I asked how old am I? And yeah, so pretty much you write whatever you feel. You can call all the modules that are available and then their function to do what you feel like doing. So there are different type of boxes. There are all the script that you use, but there is also something very interesting in Choreograph. It's the animation boxes, because when you program on a robot, there are not only the coding part, there are also what comes during the application. And you've seen Pepper, she was not speaking like this. She was moving her arms, so you have to animate the robot. You can either use a pre-made animation that we provide, or if you feel like trying, you can create your own animation boxes. It's a very simple timeline principle, so you add frames, keyframes at different time, and with a certain position. So if I click here, Pepper is gonna go in the position that is determined at this point. And the same goes for here. And the robot handles by itself the joints interpolation that allows the movement to be very smooth. So you can, on top of that, add layer of behavior. So here, for example, there were boxes dedicated to the eyelid to make it a bit more alive, and also something for the sound. So this was the take a picture animation that didn't work. So if I try, it goes like this. So it's quite easy to program, and it's very interesting to play with. And finally, we have something that have been developed also in the software, which is handling the old dialogue part. Because this is an important thing when you developed on the robot. You need to think about how it's gonna go in the interaction. So this is what we call a topic. It's where you write down all the dialogue that you want in the application. And you have to write down everything, pretty much. You can use pre-made concept, so to reduce the work, but basically you have to think about, okay, what the robot is gonna say, what the human is gonna say. So the structure is quite basic. It's, you write down the human part, and then you add the robot one. And you can connect all of these dialogue things to events or to animations in order to make it very complete. So this is, yeah, a basic example of what you can do. But yeah, if you won't feel like giving it a try, you can. And the second thing I wanted to show you is related to Java, because here it's quite simple. And okay, so here I've got an example of how you can do things with Pepper in Java using our SDK. Sorry, I'm trying to adjust it a bit. So basically you import the SDK, and then you can write pretty much as you do as usual. So the only thing you need to do is to connect to the to the robot IP, and then here it's a very short example of a little application. So you start your application, and it's going to open what we call a session. A session is what allows you to connect to the robot, and then you will be able to call through the session all the modules that are all the services that we provide. So for instance, here we have the all IL text-to-speech, which is what makes, among other things, the robot speaks. So we call that one, and then I set the language to English, and I told him to say, oh, I can change that. Hi, everyone. And then we added something with the IL memory module service that we saw earlier. So to open in the session, every time the event middle tactile touch happens, you print touch it, and you also say, oh, someone is touching my head. So we have a lot of different events you can subscribe to. So if I try running this one.
Hi, everyone. Someone is touching my head.
It works. So it's cool. But yeah, basically, I'm not an expert in Java, but you can do pretty much a lot of things using this. So we can come back to this. Okay. So now that I've shown you like how easy it is, I would like to talk a bit about what is around all of this, because an application itself is not, it's good, but you need something around. And for that, we are trying to build an ecosystem for the platform, for the robot. So we want people not only to be able to create application, but also to distribute them and to get feedbacks from the people from their application. So, yeah. And also something that we hear a lot is, what does people create? What do we do with paper? So it has been on the Japanese market for 2 years now, and we have a lot of different example of application of services that have been built by people. So here is, for example, Nestle. They were one of the first to buy paper in Japan and to implement the robot in their stores. They built their own application. So it was mainly to promote their Nespresso coffee machine. So they added a lot of different service in the application. But we also had trials and application in Europe. In Carrefour is a big shopping mall in France. Maybe you know. But yeah, basically they also built their own application for the needs. And something interesting is they did some product recommendation. And you could tell me, okay, but a human could do that. But actually, the cool part was there was recommendation for the wine. It was France, so. And the thing is, sometimes people in France, they don't feel comfortable asking for advice about wine because we're supposed to know everything about wine. So it's a bit awkward to ask to a human, but you have no, you can ask the robot because it's not gonna judge you. So that was one of the big hits of the application. And we had other example. This was the French railway station. And also, this is a cosmetic store in Japan. Yeah, they put the little hat, Japanese. And yeah, so we are working with big companies. They are investing money in paper, but it's not only interesting for big companies, it's also interesting for small developers. We have some stories here. These three guys they were at the beginning just robotics enthusiastic. They joined our developer program at the very first beginning, and they bought a Now, the small robot, and they start developing application as an hobby. Frank at the top, he mainly created application related to his son because he had a kid, and he started to develop games and education application on the robot. And a few years later, in 2014, he launched his own company that is now building only application for robots. And actually, they are the one that developed the application for Carrefour. So they are starting to grow. The same goes for Carl. He was a very big fan of Now. He founded one of our user group in London, and he launched his own company in 2014 as well. And yeah, finally Xavier. It's a French former IT manager that also was very fond of Now. And he now runs Humanoid, which is also a robotic startup that is building application on Now and also soon on paper. So yeah, it happens, and things are growing a lot. The very interesting thing is that we have been on the market for a few years now in Japan and also in Europe. So we are starting to have very nice feedbacks about the development of application, so that developers we can take advantage of all of this experience and try to make application even more, even better for the users. So one of the lessons we have so far from our experience is the need to have robot-driven application. Because at the beginning, there was application like this. The robot was not proactive, and the person was coming in front of the robot and with a lot of expectation mostly from the fiction, and starting to ask very things that the robot could not do. So we started to think the other way around, with applications that are initiated by the robots, and there are sensors that allows you to know if someone is approaching, so you can have different stage of calling someone and seeing if he is interesting, and then offering the different things that are running on the robot. So this was very important. There was also, it was supposed to be a GIF, but it's not working. But yeah, animation, as we saw in the software, is very important. We need human-like movement. Otherwise, it gets very creepy. And yeah, so people are starting to realize that you need to think about the animation when you develop an application. We also have, that one. So here, it's an example of something you should not do, which is having only one output from the robot. When we speak as human, we have a lot of different words to say the same things and a lot of different expression. And it has to go the same for the robot. First, he has to know what good morning, hello, hi means, and that they are all the same. So you have to, when you program, you have to think about all of these possibilities, that the person in front of the robot might not say good morning, but just hi, and the robot has to answer the same way. And yeah, same goes for the outputs of the robot. You need to have different things he can say, because if he always repeats the same phrase, it gets really boring. So yeah. And anticipate design failure, because sometimes when people interact with the robot, the environment is not that good. So you can have a lot of noise, and for example, the robot doesn't understand what the answer was, and it can lead to strange situation where everyone is waiting. So in this situation, we need to think about, okay, what is my backup plan? What do I do if there is something that goes wrong? So what we can do, for example, with Pepper, and we started to do it, is if the robot says something, ask a question, and it does not understand any answer, it displays on the tablet, on the chest, the different proposition. So then the user in front does not get lost, and it can catch up on the flow of the application. So yeah, we have a lot of good feedback about this, and there is more and more people getting interested in the field of robotics. And we believe, even if you don't feel like building robotics application, that it's something we have to take into account, because as mobile came into our world a few years ago and we had to adapt, I think we believe that robots are also coming as a new interface, and that we think we need to, and we should try to anticipate this and to see how we're gonna adapt our businesses to it, and how we're gonna handle these new machines coming over there. So, I forget that one. But yeah, that was to say that when you build an application, as we mentioned earlier, it's not only about coding. You need to also think in terms of animation, in terms of dialogue, and so you need to have different skills when you are working on this kind of application. So I hope maybe I will see some of you in the future in this amazing adventure. So if you have any question, feel free to ask. Thank you for your attention. So, for me or for paper, I don't know. Actually, it was what I was trying to show you, because I've got in choreograph. Normally, I've got a view of the dialogue of what the robot understands, and here it's gone because I tried to put it on the other side and I don't have it. But basically, the robot has a certain percentage of certitude about what he hears, and if it's under 50%, it's not gonna say, okay, I'm sure the human said this, so I'm not answering. And that's what happens. It was under 30%, 50% of being sure that I was asking him to introduce himself, so he did not. But he's able to introduce himself. So yeah, that's what happened. Maybe as well. And also the fact that here I've set up a box called Basic Awareness, which is basically telling the robot to find a face. And then when you find the face, you listen what the person in front of you is saying. And I don't know why, but he was not trying to find me at the beginning. So he was not listening my way. He was like listening around. So plus the sound of the micro, it might be something like this. But yeah. So.
Can you tell us something about the algorithm used internally by the robot? For example, do you have some sort of neural networks of fuzzy logic or rule engine, or I don't know?
No.
Okay.
I'm sorry. This I can try to find answer about this, but I don't have like the background for this one.
Okay.
Sorry.
Thanks.
Is there some API for kind of machine learning of this robot? I mean, so that it adapts somehow to what you say, to the dialogues?
There is no machine learning currently in the APIs, but we have some, for example, here, when it comes to face recognition, I can tell the robots, where is the mouse, to memorize someone's face. So it's like a face. Okay, here I've got face recognition. So basically, it allows you to create an application where the robot is going to interact with someone he knows. So you have first to make him memorize a face and to assign a name. So yeah, this has the small machine learning that we provide. It's not real. You have to program it. You have to say to the robot to memorize the face. It's not going to do it by itself, but then you can use this kind of things that he learned to program. So yeah, but that's pretty much all, I think. NowKey, no. It's not open source, but yeah, no, it's not open source. I don't think so for now. You, you can create your own services. So you can create new services to NowKey, which is a way of improving what is already capable of. But yeah, I think that's pretty much all. For NowKey, it's mostly C++ from what I know. Yeah. other question? Or if you want, you can try to interact after with Pepper or ask other questions. Okay, thank you.